So another example, this time just increasing the complexity a bit. We'll not do the method of sections this time, we'll just try and do the quick rules to figure out the bending moment diagram of this beam. And we've got one more thing we've chucked in here, and that's what happens to the bending moment diagram when you've got a couple or a pure moment. So if you've got something like this, so we'll just cover that. I might do one section just to cover that and just have a look at what happens to the bending moment diagram across that. Otherwise, we'll kind of use these rules we've come up with. Now, I just looked at my calcs for the shear, and we're just looking at, I don't know why I called that VA. It's really just V2 or 2 minus. This is V2 plus. This one should be in V4 minus, V4 plus. Okay, so sorry about that. I'm not sure why I wrote that as VA. It should have just been like the other examples. Okay, so let me just tidy this up. I'll be back in just a second. So I got rid of all the extra working. So to find the shear force diagram, remember we just found the reactions, and then I think we did method of sections for this one just to show it was jumping, but we could just use the quick rules. So force goes up 7.5 kilonewtons, goes along to the 10 kilonewtons, goes down 10 kilonewtons, so you get to minus 2.5 and so on. And so we could figure out that shear force diagram really quickly. And with the rules we've got, especially when it's point loads, we can also figure out the bending moment diagram really quickly. And so let's just have a think. If I imagine this beam, so you've got a beam supported, most of the loads are down the way, the majority of the loads are going down the way, so it's probably mostly going to be going in the negative direction. And we could, it's going to be mostly a sagging moment, therefore it's mostly going to be a positive bending moment because it's going to be sagging. And so it's going to be something like this, do you know what I mean? Because most of the loads are downwards. But, what else was I going to say? And then sagging is positive, but on your bending moment diagram you're doing positive downwards. And I'm just trying to get a rough idea of what the maximum magnitude is going to be. So we're going to start at 0, and then we're going to go. So I'm just thinking about the rule we have. So we're just going to say for each meter along we go, it's going to be the area under the shear force diagram. So just be careful. It's not the UDL. If you're looking at UDLs, it's the shear force diagram, the area under the shear force diagram. In which case, let's have just to think about that. So we're going to 7.5 kilonewtons times, we've got about 2, yep, 2, it's going to be about 15, but then it's going to start going back down again. Maybe it's going to be about 15 or something like that. Let's just try it and see what happens. I'm just going to move this so it lines up with some squares, make our life a little easier. So let's try and draw this bending moment diagram straight from the shear force diagram, knowing that it's going mostly this way. And so we're just going between forces. It's going to be straight line between forces, and when we get to this little moment, we'll just do a couple of sections to figure that out. Oh, come on. Okay, so we're thinking under the shear force diagram, for every meter along, the moment's going to change by the area under the shear force diagram. So 1 meter along, you can do 1.75, so it's going to go 7.5 kilonewtons positive direction for the moment, which is downwards for moment. So it's going to go 7.5 for every meter. So then we're going to get to about 2.5 here. Let me just draw this on. So we're going to have a moment like so. It's a straight line between point loads. Then what's going to happen, so now we've got negative 2.5. So let's just, I'm just thinking about what that means. So for every meter we go along, we're going to be going negative 2.5, negative in the bending moment diagram is up the way. I just need to put on what this is actually. And I might have chosen a scale that's a bit too low, but that's okay, we'll stick with it now. So that, let's say that is, in fact, it's not going to do. Let's fix this up. So we'll do +5, 10, 15 positives down the way. Then we're going to go 7.5 for every meter we go along. And so by the time we get to the 2 meters along, it's going to be at +15. So it's going to be at +15. Then we're going to go -2.5 for each meter we go along. So -2.5 for each meter. So by the time we go 2 meters, we're going to go on back. We're going to go down. Well, we're going to go up, but we're going to go negative by 5 kilonewtons by the time we've gone 2 meters. So, and it's just between point loads, so it's going to be a straight line. Now we get to this 10 kilonewton meters. So we've got a concentrated load here. So let me just, I'll quickly draw some sections and we'll just see what happens as we cross that. You can probably guess it's a bit like a point load for the shear force. It makes it jump. The same thing happens for a moment diagram. So the moment diagram is going to jump. But just give me 2 minutes, I'll just draw that out. So we're just trying to figure out what this little concentrated moment does to the moment diagram. Because I'm not sure, going back to the sledgehammer, I'm just taking sections just on each side of that. So I'm taking one section at just less than 4 meters and another section at just more than 4 meters. And so just going on each side of this little point, and we're seeing what happens to the internal moment as we go across that point. And so let me just keep looking at that. I'm just going to go back through and change some of these. I just said 2 minus. It should really be 4 minus. We're at 4 minus and 4 plus. So just fix that. That should be 4 minus. 4 minus. So it's just a little bit less than 4 meters along the beam. And this should be 4 plus. 4 plus. You've just gone just past that concentrated moment. So I've drawn the free body diagram split, put on my usual reactions, and I'm taking moments from this end so I don't have to actually worry about what this is. So if I go through those calcs, just as usual, you work through them, we're getting M, so the moment here just before that little concentrated moment, just before that we're getting it's 10, should have some units on that, kilonewton meters, which is what we got from this method, 10 kilonewton meters. So that's good, at least we're heading in the right direction. Then just gone past that point load now. So I just did on this side and just gone past it. And so what we find is that that moment appears, the 10 kilonewton meters, and it's a -10, it's going in the clockwise direction, so it's -10 kilonewton meters. So we just work through this again. And so it's all the same. The only thing that happens is that pops into the equation. And so that -10 kilonewton meters pops into the equation. And so then if we work that out, then we're going to find that -10, that's correct. So we are going to get, this is all -10, it's the same as before. So we get -10 minus another 10 plus M4 plus is equal to 0. So then M4, just a little bit past 4 meters, it's going to be 20 kilonewton meters. And so the moment is going to jump, and it jumps by the negative of that point load. So it jumps, and so this one is negative, but it's actually going positive 10 kilonewton meters, which in our diagram is downwards, positive downwards. So it's going to jump like this. Just draw it on. So that point load is making it jump down like so. And it's going to go to 20 kilonewton meters. After that, we just do the same as before. And so we're just using this rule that we just look at this UDL for each meter along. That's going to be, the area under there is 2.5 times 1, so it's just going to be 2.5 kilonewtons in the positive direction for each meter. So it's going to 2.5. So by the time it's gone 2 meters, it's going to have gone up by 5 meters. It's going to go up to 25. bending moment diagram is going to go like this. Then it's going to go down 12.5 for every meter. And so over those 2 meters, I'll line this up right. Yep. It's going to go down 25 kilonewtons. So for each meter, it's going to go, the bending moment's going to go negative. So it's going to go up the way by 12.5 kilonewtons. So it's going to go back up like this, and it's going to get back to 0, which makes sense because we've got a pinned connection at this end, so the moment is 0 at that end. And that's the bending moment diagram. A bit funny looking, but that's what it is. And so that way it was just following the quick rule. The quick way of finding, why did I do that? I don't know why I did the graph in black and the shading in red. We probably should have done the whole thing in blue, to be honest, to make it look nice. Please shade it nicer than I'm shading it. And what we should do is we should just write on the values at the peaks. And so we've got, this one is 15 kilonewton meters. This one, and probably any place where it changes suddenly, we should write it on. This is 10 kilonewton meters. This one is 20 kilonewton meters. This one is 25 kilonewton meters, all positive. You're always thinking about this fact that it's weird because down is positive, and this back to 0, don't need to put that on. And that's the bending moment diagram for this one. So not too much of maths involved, and you can even avoid the maths for this point just by remembering that what will happen is if you've got a negative moment, you'll get a positive jump in the bending moment diagram. If you had a positive moment, if it had been going the other way, you'd have got a negative jump in your bending moment diagram. So it kind of does the opposite of what the pure moment is. So you just got one more thing to look at, and that's for line loads for the bending moment diagrams. So we'll have a quick look at those, and then we're done with all the different stuff. We'll just try and bring it together with a few more examples and a list of all the different rules we have so we can sketch these bending moment diagrams and shear force diagrams. Okay, so one more example to go, and then we'll do a few examples to kind of draw it together in some